So now we're going to ask ChatGPT to give us another problem. And in chapter 8, there's this situation where the population mean, where we need to do interval estimation for the population mean, and the population standard deviation is known, but there's also the situation where we need to do interval estimation. We're estimating in an interval, right? What is the population mean? And we're doing that based upon a sample. And we're doing that in a situation where the population standard deviation is unknown. So now we need to ask ChatGPT to do that. And so I'm just going to copy this from up here, Control C, and then Control V, paste it down here. And I need to change this, so please give me a simple problem to solve myself to help reinforce for me the concept of interval estimation in statistics for the population mean. And I'm just going to take out in statistics, it reads better. For the population mean when the population standard deviation is unknown. So now I'll put that in there and take a look at this problem. And we'll get our little notepad. And we're just going to bring our notepad over here and not look at anything beyond that, because that's all we want to do right there. And so a researcher is studying the average height of a particular plant species. They collect a random sample of 25 plants. We're going to go 25 as our n, lowercase n, and measure their heights. The sample mean height is 150 centimeters. So we got 150 for our sample mean. And the sample standard deviation, so we're going to change this to sample. Standard deviation is 10 centimeters. 10 centimeters. Construct a 90% confidence interval for the population mean height of the plant. So we're going to go with 90% there. And then we will change this down here. And so we're going from 150 plus or minus. Oh, we got to go get our formula. So we're going to come over here and we're going to scroll down to the situation where the population standard deviation is not known. And we're going to look for the formula. And, remember, we got to use the t-table now, right? That's good. And so this looks like a formula. So we're going to use this formula here. So now I will bring this over on the right. There we go. And so we're going to have the sample mean, 150, plus or minus, and we need our t-score. And so our t-score at the 90% confidence level, so just look this up online. But, when you look at it, and this is from this URL right there. So if you want to type in that exact URL, you could do that. And when I look at this, I have 90% confidence level. So down here at the bottom of this one, it just tells you, hey, this is your confidence. So here's 90% confidence level. And we need this when we have a certain number of degrees of freedom. And our degrees of freedom is going to be our sample size minus 1. So 90% degrees of freedom will be 24, right? So we're at 1.711. And 90% means that there's 0.05 in the upper tail. Okay, so that's our 90% confidence level. I'm kind of glad that they have this down here, because with the z distribution, it's really easy for me to see that, you have those two tails. So here is like the z distribution one, right? It's like, well, there's one, there's the other. So I take alpha and divide it by 2. But then with this one here, with t distribution, right, they didn't give me a cool little picture of t distribution. Maybe that's why it's confusing for me. And when I do see a picture here, it's saying from this point over to the left, like that's what you're calculating. And that's just like the Z one. It's from this point over to the left. But I didn't get that picture in here like I did with Z, where it's like showing me the two tails. And because I didn't get that, I'm kind of like, which one? Which one do I, how, But I'm glad it's like 90%. Is 0.05, because that means they've divided this by both tails. So probably in the textbook it says that's alpha over 2. And alpha over 2 is, what is the terminology? Alpha over 2 is your level of significance, aka your alpha, right? So your level of significance, your alpha, needs to be, oh, it's right there, alpha divided by 2. So that's brilliant, it's right there. So all figured out, man. 90% is 10% divided by 2, which is 0.05. And so it's 1.711. What is that 1.711? That is the number of standard deviations that we need. And how big are the standard deviations? Now we have to calculate that, and it's just going to be S, which is going to be the sample standard deviation instead of the population standard deviation. That's going to be 10, and it's going to be over the square root of n, which in this case will be 25. So it's really a pretty similar formula, but all you're doing is using your t distribution and your sample standard deviation as opposed to your population standard deviation. And now we can go do the math. And so to do the math, I'm just going to copy all this, Control C, and I'm going to move this over just a little bit, just have a little divider, and I'll just put a little color there just to make it like a divider. That's fine. And then we need square root of 25. All right, and so we'll add that in to this formula, square root of 25. Cool. And then we're going to have 1.711 right here times, and then this is going to be 10. And 10 is our sample standard deviation. And then this one's going to be D2, which is the square root of 25. So we're going to hit enter on that. And then we're going to have here, it's going to be 150, because that is the sample mean, plus or minus whatever that answer is up there. So I guess we should change that now. And it's going to be plus or minus 3.422. And then to do the math on that, it'll be, and that's going to be, where's the 150? That's just our, because I didn't have that accessible to reference, so I'm just hard coding that in. Well, I think I just do it like that. There we go. Just pressed into, so there's our interval estimation. So I'm just going to copy this here. Well, I'll copy each one individually. I can just do it like that because I have my little notation already. Boom, and copy this and put that in here. Boom, and that's it. And so I could hit escape to get rid of my little marching ants showing that that's been copied. And I could come over to ChatGPT and I could say this here. And I'm going to, is that chat? Yeah, that's ChatGPT. I'm going to go here and I'm going to do this. And I'm going to come down here and paste. I'm going to do all this over here. Boom, boom, because I have, I am 95% confident that the true population mean lies between, boom, boom. And are we dealing in grams? No, we're dealing in centimeters or something. Centimeters. cm. Whoop. And this one here. Boop. And this one here. Boop. And this boop. And this one here. Boop. Yeah, pretty amazing. I was going to share something with you, but it's a little bit personal. All right, and I'm going to just paste that in there, and I'm going to press enter. Oh, I'm 90% confident, and it's going to correct me. Great effort. However, it seems like you calculated 95% confidence interval instead of 90% confidence interval. As requested in the problem, let's double check your steps and go over the process for 90% confidence level. Sample mean 150, sample standard deviation is 10, sample size is 25, degrees of freedom is 24. Since the population standard deviation is unknown, we'll use the t-distribution for a 90% confidence interval and 24 degrees of freedom. The t-score is approximately 1.711, that's what we got. Margin of error is this part, right? It's t times how many standard deviations times how much is, what's the amount of a standard deviation. So it's 1.711. Give me 1.711 and this quantity of standard deviations, and then that's my standard deviation, and it's called the standard error. And then we get 3 point, and then the confidence interval is going to be 150 plus or minus 3.422 or 146.578 to 153.422. So your answer was actually correct, but you used the correct t-score for 90, and therefore you're 90% confident that the true population lies between this. Awesome work. Does that process make sense now? Yes, I accidentally typed my answer with 95% instead of 90%, my answer should have read. And now we'll copy this, boop, 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 and then put that in there and hit enter. Yes, exactly. You've got it now. Yay! You're 90% confident that the true population mean lies between this and that. Well done, and keep up the great work. If you ever need more practice or have other questions, feel free to ask. I'm going to press the Windows key and then my period. That's how you bring this up. And then I could do this or whatever and, you know, put in my little emojis and send my emojis to ChatGPT. I'm always happy to help. Feel free to reach out anytime. You're doing great. All right, so that's our review of doing interval estimation for the population mean in two different situations. One situation where the population standard deviation is known, and one situation where the population standard deviation is unknown. Yeah, so that's it. All right, I have a question for you. Leave this in the YouTube comments down below. Do you like me better when I'm like talking loud and amped up on caffeine? Or do you like the lectures better where I'm a little bit more quiet and just kind of doing it like this? Seriously, whatever your perspective is, I want to hear it. So leave it down below in the comments, and I'm curious. I'm truly curious. Like, I'm not trying to get comments just so I could get views. I'm just curious what people think. So let me know what you think. Because I make video lectures a lot, and so if people prefer this method better, you know, maybe I'll just try the more chill method, and we'll see how that goes instead of being all cranked up. All right, see you in the next video. We're going to step into chapter 9, and chapter 9 is going to be pretty much, where's chapter 9? Where's chapter 9? That's chapter 8. Chapter 9 is right here. Chapter 9 is going to be pretty much exactly what we did in Chapter 8. That's what Chapter 9 will be, except we're going to apply this concept of hypothesis testing. So we're going to have a hypothesis, and our hypothesis will be, hey, something is this way or it's that way. And then we're going to use interval estimation, and we'll do it in two situations, right, where the population standard deviation is known and the population standard deviation is unknown, right, to determine if our hypothesis is correct. So it's really everything you already know, and we're just going to learn a few new vocabulary words, like what is a null hypothesis, what is the alternative hypothesis, and then what's a type 1 error, right, versus a type 2 error, and we'll see this little thing here to do that. So we'll learn those, and then we're going to apply it in a situation where we want to do interval estimation and to find the population mean, and we'll do that in two situations where the population standard deviation is known and where the population standard deviation is unknown. So really the skill that you got in Chapter 8 with interval estimation, we lean on this for, you know, I think at least the next two chapters. And so it's just all, you know, a lot of the rest of the semester is just doing exactly what we were doing here. Like, hey, what is, why would they want to show me notifications? No. Why, you know, we're doing like, what is my z-score or what is my t-score, right? The population standard deviation is unknown, so I need to do my t-score and use my sample standard deviation or some estimate of the standard deviation. So that's what we're going to do. See you in the next videos.